Spacecraft today are performing more complex manoeuvres than ever. Some of the biggest challenges that engineers face is that there's a lot of new key technologies emerging, operations such as docking and refueling and servicing of spacecraft.
And that means that there needs to be a lot more precise control of these satellites. Fuel movement especially is very hard to predict. Sloshing needs to be measured and controlled to be able to have satellites approach each other accurately.
In microgravity, liquid fuel does not settle the way it does on Earth. Instead, it can move and oscillate inside the tank, a phenomenon known as propellant slosh. That motion can subtly change a spacecraft's dynamics, affecting its attitude and trajectory. During precision operations like docking, even small disturbances can matter, which is why understanding and accurately modelling propellant slosh is critical for mission reliability and safety.
SLOSH-CAT is a project that aims to measure sloshing in a fuel tank. We do this with our 2 robots here that we use to simulate zero gravity. We can then use the data to inform a digital simulation to figure out what the sloshing is doing and how to counter that when we try and control satellites.
The SLOSH-CAT project is funded by the UK Space Agency, made up of a consortium of ourselves, the Satellite Applications Catapult, the University of Sydney, who are doing the simulation side, and the Space Machines Company, who have a spacecraft that they are planning to launch in orbit.
Our engineers monitor experiments from a dedicated control room, allowing us to observe how fluid motion interacts with spacecraft control systems in real time.
We apply it to a spacecraft control algorithm, and it gives you a lot more confidence that the simulation is going to be performing in the way that you expect it to.
The Satellite Applications Catapult's ISAM yard is a specialised test facility that simulates orbital conditions using industrial robots, motion tracking and gravity offload system. Our equipment can perform close proximity manoeuvres such as docking and servicing of satellite mock-ups, as well as assembly, inspection, repair and refuelling trials, enabling technologies to be validated on Earth before deployment in space.
Modelling slosh is critical to being able to understand how satellites perform when they're up in orbit. It gives the UK a very unique capability that can help industry move forward to develop the technologies.